Good evening, Professor Dan Miller. I am Adila Antar Ali from Section DO1 of your Introduction to Engineering course. For my first video, I have chosen to discuss my understanding from the project matters so far and my plans to develop it in future. The tension on a single rope at any point is equal as long as it is taut. The pulley system provides us a hinge to divide the effect of a rope or a string. By this division, the effect of the pulling force is multiplied because it appears as though there are multiple ropes pulling on an object at the same time instead of just one. There are two basic principles that govern the usefulness of a pulley system. The first is redirectional force, which can be achieved using a single wheel and a rope. Pulling things down is always much easier because of the gravitational force that aids us. And redirectional force is convenient, but the force that has to be exerted remains the same, which leads us to our second objective. The second kind of advantage is the mechanical advantage, and that is basically multiplying the extent of our force being exerted. In our double pulley system, we can arrange the system in such a way that it appears as though there are two ropes acting on the object instead of just one. The length of the rope is doubled, and each half of the rope bears only half the weight of the object, which means that whichever half we are pulling on, we only have to exert the force equal to half the weight of the object. The aim for this project is to implement both directional and mechanical advantage to our double pulley system. Another factor to consider is the number of loops the rope will make around the wheel. The greater the number of loops, the more length of the rope we will be utilizing, and the lower the amount of force we have to exert on each section of the rope. For the time being, I have considered making 3 to 5 loops around each wheel of my double pulley system. To detect the practical output of my project, I will be measuring the mass of each of the 3 objects in kilograms and multiplying them by 9.81 to find out their weight in newtons. If my project is functioning properly, the amount of force I have to exert on any section of the rope will be equal to 1 over the number of sections that I have into multiplied by the weight of the object in newtons. Thank you.